So, my name is Martin Furuhed. I work for Nexus as product manager for, and I'm responsible for a couple of products in the PKI area. It is software that is used for issuing, managing, and life cycle management of certificates, revocation management as well. And I will talk about the cooperation that SICS and Nexus has on bringing digital certificates to constrained IoT devices. Before we go into the details of identities and certificates, I will just give a very brief overview of Nexus and what we are doing with identities. We have a history since '84 and have a main office in Stockholm and offices in all Nordic countries, Germany, France, India, and the US. So the products that we provide for management and use of identities allows both digital access and physical access. So it's both related to physical entrance systems as well as digital access. And our customers, they use the software for securing internet bank access, entrance to the physical locations, digital signing solutions, replacing passwords with strong authentication, and a lot of other things that you can do with based on PKI and physical access cards. So many of these top solutions are based for humans, of course, but what we see now is an increase of identities for equipment, computers, and down to constrained devices. The basics for electronic identification then in form of electronic IDs can be used by people and software for accessing securely services. So an EID, compared to another authentication method, it also allows doing digital signing, which is the big benefit of PKI compared to other authentication methods. And if you take Sweden as an example, we have the Swedish citizens' use of bank ID is a good example of what the technology with PKI can lead to, and that it can be useful for the whole society. So it's a very mature technology in Sweden. So there are many similarities when it comes to use of PKI digital certificates comparing traditional use for authenticating people, and then if you compare to constrained IoT devices. But of course there are many differences as well. To get a picture of what are similar and what are different, we can take a look at the traditional or almost daily use people have for using a browser for logging into an internet bank. The electronic ID, it consists of the private key pair and also the certificate, which contains the public information like the public key and user information, which is used to identify the person logging on to the web service, for example. So the purpose of the certificate is obviously to prove to both sides who the other one is. And as long as the certificate has been issued by a trusted authority with the proper registration authority mechanisms to do the initial authentication of the individual in the right way, you don't end up with a faked electronic identity. The information can then be trusted, and it is issued by a certification authority, the organization and the software used to create the certificate. And that's the software we provide in this project as one part. And the work we are doing is looking at how to reduce current methods of enrolling certificates to devices, or from how it's used today to enroll identities to people, how we can reduce that into the devices. And if we go over then to identification of equipment, the same principles are used. And but in this case, the identification is done without any involvement of a human being. And the similarity here on this level is that the certificates are in principle identical to the ones used by people. The content can be different, but the same standardization is used. And when we talk about closed networks, like in the mobile operator backhaul infrastructure, the equipment is quite powerful. You usually have an administrative user interface where the administrator can request, generate a key pair and request a certificate from the certification authority. And so that's not a problem really to deal with this big equipment, the powerful computers, and in this enrollment process of certificates. So where the key is certified with the certificate from the CA. But then when it comes to the growing number of small IoT devices, things gets a bit different. Today, security can be established in a smaller scope of devices using symmetric key cryptography. But that does not scale very well when it comes to the huge volumes that can be expected in the future. The good thing, though, is that using traditional PKI and certificates, that's a technology that is very suitable for constrained devices as well. But there are, of course, other problems that has to be solved, like lack of user interface, and that the computing power is very reduced in the constrained IoT device. It may not even be able to generate a key pair, and so that can be a service of the CA to actually generate a key pair and submit that to the device. We have battery-powered devices. When activated, they are unattended for several years, and they have to be able to manage themselves the certificate issuance, and that's one part of the work we're doing now, is finding out how can a device request a certificate without a human being getting involved. So there is a need for an automation of certificate issuance by having some logic in the firmware of the device to take care of the normal administrative management. So when it comes to IoT security, what we are focusing on in this project is obviously enrollment of certificates to devices to enable devices to communicate securely with each other, and also one of the important things is that when you deploy a huge number of devices in an office building, you want to be sure that it's only legitimate devices that you connect, so you don't get someone else's small device into your network. So the certificate has that purpose as well, then, that you know the devices that you connect, you can approve which devices you want to communicate with. So that's what we are dealing with in these projects, but there are a lot of other aspects for manufacturers and purchases of devices, like tamper-proof or tamper-resistance of the firmware, having no default passwords, and how to securely update the firmware if that has to be done. And the other part is that these devices, like sensor nodes, they collect data and they publish that somewhere. That can, of course, be sensitive information. So then we have the sensitivity question relating to GDPR, for example. What do you do with these measurement data? Who has access to it? Can you rely on the data being collected in a database? How can you be sure that it is a legitimate sensor that has provided this information? So there are a lot of things to consider when it comes to IoT security, of course, but then in our project, the cooperation we have, SICS with Shahid are responsible for leading the research work and taking care of the client-side implementation of the technology, and the Contiki OS is the expertise of SICS, so that's the platform being used for implementing the new standards and technology that we develop. So because of the constrained devices, we have to reduce data wherever it's possible. So the traditional HTTP protocol cannot be used. We use constrained application protocol instead. Instead of TCP and TLS, it's UDP and DTLS. We have to take care of to manage the slow wireless connectivity. And as I said before, the problem of automatically requesting a certificate has to be managed by the device itself. And when it comes to type of keys, it is the elliptic key cryptography that we use and not RSA keys, because it's a considerable difference in size. And at Nexus, we develop a CA software that we provide for closed PKIs or public PKIs for countries or smaller organizations. And the role of the CA is to ensure that the one who obtains a certificate is the correct individual. But that applies also for devices. And so we approve requests, sign certificate, do revocation handling, or decide to use a short-lived certificate instead if you don't want to deal with revocation. Key lifetime, etc. So there are a lot of policy configuration to be decided and handled by the CA. And what we are adding now to the product is a suitable enrollment protocol to deal with these, to support these small devices. So one CA can then support issuance of certificates for people, powerful equipment, and also now to the constrained devices. So that's why we are so interested in this cooperation, and I think that now we finally have methods available for doing this. And the first project that we've been cooperating in is called CBOT, Certificate Enrollment in Billions of Things. And the objective was to equip devices with capabilities to obtain certificates in a secure way and automatically, and built on the protocols that these devices use. And when it comes to this method of enrolling for certificates, there are today standard protocols that are used by powerful devices. And there is one called EST that we now have adopted to deconstrain device capabilities. So it's a fairly new protocol, this standard-based protocol, defined in 2013. It's by default it uses HTTP, and it takes the previous protocol, enrollment protocols, the best parts of it, and combine them into a new, more easy to implement protocol with support for ECC keys, downloading of CA certificate, and doing initial certificate issuance and renewal handling. And it can even provide service-side generated key pairs, for example, using a hardware security module, an HSM, and submit that to a device which may be incapable of generating key pairs itself, or want to avoid that to save battery power. So the result of the SIBA project is that there is now an implementation in Contiki for EST over CoAP-S, and we have the support in the server to issue certificates over this protocol. And there is a draft prepared together with Philips and Cisco on this work. And currently there are papers being written where you can see results and do comparison with the traditional methods of transferring certificates, like the CoAP protocol provides a very little overhead in the communication. The request to obtain a certificate is very small, and the data returned back to the device, in form of a certificate. That's of course the result provided by the CA, but it's fairly small sizes in all. So that's the SIBA project. Now we started up another project called Secure IoT, which is a Eurostars project, and by that involves also can involve countries from outside Europe, and in this case South Korea, where we have cooperation with a couple of universities and a couple of companies who use Contiki, by the way, for sensors in pump stations, which they are interested in securing connectivity to now. So we continue with this project where Seawood ended, and that is to find a solution for how you issue the first certificate. I mean, how do you initially identify a device when it doesn't have a certificate? So this is a chicken and egg problem, to have a secure method for this first certificate. And as we saw on the previous page, the content, the size of the certificate that we transfer, we will try to reduce the size of the certificate by standardizing on the template and also reducing the compression of the certificate while in transfer over a wireless network. When it comes to revocation in PKI, that is done by a different channel normally, but in the deployment of IoT devices, there might be a need for a protocol for doing revocation built into gateways or whatever it might be suitable. And the result of this will also hopefully lead to some standardization and new functionality in the products that we provide. So at the current state of the Secure IoT project is that there has been a master thesis being made to looking into this compression of certificates in transfer, which shows quite positive results. And then when, as my last slide here, we are now looking into yet another project which we will apply for in a very big consortium on the European level to investigate and bring secure communication to environments containing a lot of different kind of equipment, from small IoT devices to vehicles and people, wearables. How should all these components be able to communicate securely in between each other? So that was it, and if there are any questions, open up the floor.